My name is Hannah Lee. I am based at Heriot University and I'm a PhD researcher. I work with the DEEP project as well as with the Scottish Blue Carbon Forum from the Scott Government. And the talk that I gave yesterday was about blue carbon in bivalve habitats, specifically talking about blue mussels, but I also work on the native oyster.
Could you tell us a little bit about what blue carbon actually is?
So blue carbon is the carbon which is buried and considered as being deposited into our oceans. Traditionally people think about green carbon, and that's really easy to conceive because that's the carbon in our trees, so think the Amazonian rainforest, whereas the blue comes from it being the ocean.
How important is blue carbon in the fight against climate change?
So in terms of climate change and the Climate Emergency Declaration, blue carbon itself offers an opportunity for understanding of how our oceans are sinks for carbon and whether or not all ecosystems may be a sink or a source. When we begin to think about our impact on the world, if we can propagate the accumulation of carbon into these sinks, we could consider that as some form of carbon offsetting for our actions in the greater world.
And how long is this carbon typically locked up for? Does it vary depending on the habitat?
So carbon being locked up in various habitats, what the term locked up means can be very, very variable. So what is considered long-term storage is more than 100 years. But to be able to actually know whether a habitat is storing for that long, we need to actually date our sediment samples, and that brings in surveys that we have to do along with it. Whereas a short-term storage may be just the accretion of carbon over a very small amount of time, but that could only be a few years or a couple of decades.
Do we have any idea what will happen to some of these intertidal stores of blue carbon with sea level rise?
That's a really interesting question about what will happen with sea level rise and our blue carbon stores in the intertidal, because my blue mussel bed is actually in the intertidal. You do get subtidal mussel beds, so potentially the carbon will be stored. And actually when we look at intertidal habitats such as horse mussels, subtidal habitats such as horse mussels, these have always been subtidal in the Penclin in North Wales, and there's 2 metres of bed there from the glacial lag period. So the carbon likely is going to be stored there, even if the habitat was to die out, but if the habitat itself actually becomes eroded, then it's likely the carbon will be lost and will be degraded by bacteria and natural processes.
Are there any other benefits that we get from preserving these habitats and promoting their recovery?
Well, for preserving and promoting, the DEEP project is a restoration project. So that's one of the things that we do is restore habitats. We're restoring native oysters. And it's not just carbon. So there's the water filtration that's associated. That's how the carbon becomes deposited because these shellfish are filter feeders, depositing sediment down to the seabed. But they'll also be removing other nutrients. And as studies have showed, microplastics is one of the things that people talk about a lot. This has been shown to be non-detrimental to these reefs, so that could be a mode of where plastic is being removed from the environment. And as well as that, they promote fish habitat. They also supply us with a complex ecosystem where many other things go on that support other kind of species, etc.
So presumably if we're hoping to use some of these bivalves for the purposes of water quality control, we can't simultaneously use them for food production, or can we?
The idea of using bivalves for water quality control and also food production is actually something that gets discussed quite a lot in aquaculture. So there are a couple of publications that have come out recently that look at the removal of nutrients by aquaculture. So when you farm an organism, you're effectively, once you remove it from that environment, you're removing everything else that's removed with it during its growth period. One of the things you do have to consider, if you want to just use an animal for a control on water quality, what is it consuming? And it may not be detrimental to the animal, so that's fine, but would it meet food quality standards is a different story.